presented user interface pattern. Was some very interesting advice to give how to model patterns, how to evolve them, how to maintain them. So both interesting for pattern consumers and for pattern writers. And without further ado, Rene, if you're ready.
Almost.
Stage is yours.
Okay. I think that works. Everybody can hear me?
Better, much better.
Much better.
Krieg Angst, wenn du Angst. Ich brauche mal
We got plenty of those. So, also good morning from my side. My name is Rene Reiners. Thanks for the introduction, Ola. And I work at the Fraunhofer Institute for Applied Information Technology near Boston. And this picture is for you, to remind you of the nice campus we have there, but to notice this is the thing.
I thought this is your house.
Yes, I have a new information of that. This is the thing we look at when we're working on our offices, in our gray boxes, so that's just sitting, but that's for representative purposes. And I'm the associate head of the group User-Centered Ubiquitous Computing. And basically, our, let's say, motto is we try to optimize and find out the usefulness in IT for working processes for the user group itself. So we always ask, who are our users and what do they want to do with the system before we introduce the information technology. So we always have different levels. We have technologies, we have middleware approaches, integrated approaches, but you also have the application side on top, where we see where does it fit into the context of the user group. And so it's all about user-centered computing. And before I go into the topic of what we did with pattern languages, I would like you to understand what kind of approach we have and what kind of projects we do have. So first of all, no matter where we are, we first analyze the context of use. Do we have to do with factory workers? Is it for emergency response? Is it for schools? First we see where are we working, what are the user needs here, and from that first set of interviews and workshops, we start specifying requirements. Translate them and first design a prototype. That can be on paper, that can be a mock-up from a PowerPoint, click-through prototype, and then we go back and assess and say, hey, did we get the idea right? Is that how we work? And is the idea that we pursue now suited to what you need? Then suddenly you get a new loop, you get new requirements. Oh, I forgot to mention this in our first workshop, or as you pointed out, doesn't make sense to us, and so on. The kind of projects we have here is just a short overview of what we have. Of course, we are in the Internet of Things domain. We are in energy efficiency, but also important here today is for emergency response for healthcare and ACI. So, and the approach that I have with me, the modern pattern library, comes from that emergency response domain. We have a large user group, we have very different stakeholders in such a project, and within our research project, we also have very different disciplines that have to work together. And just some short anecdotes here. One kind of project is the Excel project here, where we say we have to interconnect between different research institutions. So we're talking about cyber-physical systems, but also human-system interaction. We have business-based Internet of Things. Other groups who are working on data mining approaches, on context-aware services, on data operability. They all have to be connected here. They're very different, let's say, disciplines that have to work. We did that for energy efficiency. We equipped the metro station with a middleware where we could say optimize the energy consumption. We could say up to 30% by steering, controlling the ventilation system, the escalators, and also the lights. What we did as computer science, we optimized everything. So we said the less people we have here, the less light we need, the less air we need, and the escalator can go slower. That's wrong. You can't do that. But the comfort level decreases as well. If you have less people in the station, which is very long, people don't feel comfortable anymore if you decrease the lights. Because as a matter of safety, you can't look to the far end. So you find out these things while you iterate through the product, you come up with your approaches, and then you suddenly get the feedback, I don't feel safe here. So you have the optimization in another direction. The more people you have, you can save the lights in this case. The same here. We also did some inventions here. It was a festival last year. We wanted to motivate the people to not use the electric staircase on the right or left-hand side. So we said, Bonn is the city of Beethoven, a famous musician. It's her hometown, so to say. And we said, whenever you climb the stairs, you don't have to take over any kind of interaction. You just walk through over the stairs, you just use it. And then music plays. And that's fun. People just do it. And because they enjoy it, they play famous symphonies, for example, they have sounds or whatever. And also here, we had a period of 4 weeks we could increase the usage by 1/3 and therefore save energy. And then here, a bit shocking picture, this is a bridge project, a project that lasted for 4 years. Here we try to bring together different aspects of emergency response. So that means cross-agency cooperation, cross-border cooperation. And this is a 4-year project, 16 partners in that project, 18 participants in that. And this is my example where pattern languages may be useful in order to use a pattern as a means of communication. What do I mean by that? This is, let's say, more or less typical research project structure we see here. So you usually have a project management, of course, all around, but you also have dedicated work packages for requirements engineering. Or for the domain analysis, people tell you how the firefighters work, how the policemen act in the case of emergency, how the ambulances come by, what are the routes, what are the legal regulations, who has the command when an incident happens. So we're talking about large-scale incidents, big explosions, catastrophes, earthquakes, and many people injured or lost. And another work package here is interaction design. So we have the technology on the one hand side, and we have the user on the far end, who's not a computer scientist. How do we bring these worlds together? And so on and so on. There's work packages for the technical system development, for the integration, the validation, and the evaluation. And basically from that picture, I think you can see what are the challenges in such a research project. So you have various disciplines. Just to make it a bit more interactive here, there's a wake-up call. So what do you think? What kind of disciplines are in such a project? People that you have an idea. Who could be working there? Instead of computer scientists. Who else could be there? Such a research project. For example, we have computer scientists, domain experts, people from ambulances. Who else could be there? Just some ideas.
Psychologists.
Very important, yeah. We do have. People from the social sciences also there, technical people and so on. And so everybody has individual methods and processes how to gather the information from the domain and document these things. And then the second question would be, how do they do that? How do they document? Any idea how to do that? What would you expect a psychologist to document? Any ideas? Pardon? Interviews. How do they document? Paper, report. Tons of paper. You wouldn't believe it what they do. Video footage, something else. If you ask a physician who's also in that project, what would he do? Diagrams, charts, so whatever is some kind of formality. And here is the first challenge again. You have tons of reports. The psychologists and social sciences come up with that and say, hey, I've taken 3 days of video footage. This is my result. The physician says, I don't want to read that. I want my diagram. I want a very short report in here. And this is one of the challenges we were up to. We need a lingua franca between the different disciplines here. And that lingua franca was or is the design pattern approach. So to say we need something we can write down, which is readable for everyone, without the specialized vocabulary. And so let's document the knowledge we acquire over the project from the very first beginning to the end. People who are changing the product, people are leaving, people are coming in the third year. How do they catch up with all that? They can't watch days of video or read libraries of reports. They need something brief they can work with. And that was the approach and the idea why to use a pattern language. So how can we achieve that? That they benefit, improve our project lifetime. We said in small chunks of knowledge, all stakeholders must be able to read, but also to create or at least take influence in that. And needs to be understandable by every project member. Better, I think. So what we saw here, also in the talks before, like for these instructions also what a pattern looks like. Usually you have the situation that the pattern is something that evolves over time. Then you have experts after a long period of time to say, hey, I got an idea. These are patterns that always work. Or we have the mining approach as you introduced. Then we do it automatically or semi-automatically. But we did it the other way around. Why not doing that while we are finding things out? And then directly in parallel document what we find out in the easy form of a category. So we needed to evolve in parallel to the project's achievements. And then we ask ourselves, what are the qualities? How do we formulate? What are what are the roles, who's allowed to do what in that approach, and who does what in this. And so if you look at related work, what has done before, observation was one project, saw that. And we have Takashi Ibo, for example. He locks up 30 students in a room for a weekend and says, think about a certain domain and find out the patterns. And then he unlocks the door on Mondays and says, okay, what are the results? It's a bit like that, but it's a bit different. Or you have hypotheses that are evaluated over time. Kuhn does that in this work for interactive 3D applications, for example. And so this is what we had, and we would like to have something like doing it on the fly. And here are the big challenges we have. Normally you have a tedious pattern generation. It just takes time to find that out. We have a closed author group, we have pattern experts. Basically they say, these are all faults, take them or leave them, but these are all suggestions. But you don't really have a chance of taking part in that. Maybe you can comment. That's an option you have in online repositories. And it's not always clear how a pattern is being derived. How do they get these? Those guys get to these patterns. They have an idea, but maybe you can't follow it. And these are the, let's say, or one striking thing here is missing knowledge about bad practices. It's fascinating to report things that worked out quite well because they were successful. And they have a nice research work that has been done. But it's very important to also tell the others, your community, what has gone wrong, so they can save time. Why should they do the same mistake as you did before? Why not documenting these things? So, short anecdote, domain of emergency response. We have firefighters who go into the flames, into the smoke, try to discover the people. And once they find somebody, they are tagging them. Say, you're severely injured, you get the color of red. You're slightly injured, you're yellow, and one can still walk, he's not bleeding, he's green, but he's shot. And then they report back after taking 80 victims with 5 people, so they have 20 seconds per person to do that. They return to the command post and report. First thing we did, computer scientists, here, take a mobile device with you and just type on the button. What did you get back? It doesn't work. Why? I don't take the 11th or 15th device on my belt because I already had so many of them. I'm wearing gloves and I don't have my hands free. Forget your solution. Of course, this is obvious, but it needs to be documented, for example. What did we do? We piggybacked on what they did. They already have paper tags, and we put them in electronics. So they did what they always do. They have electronics on top. They don't have to configure these things. And if they break, they still have the old approach that they need. Then some requirements we found out from the first interview. So also for the pattern library, we did an iterative approach. And from interviews, we found out what do we need to pay attention to. So in the maturity states, the structure of the library is not clear at the moment. Since we don't have any pattern at the beginning, the structure must also be flexible. So if we have a certain hierarchy, we have certain connections between patterns, they may break up later on. So maybe we have to introduce something in between. We have to split them up. We have to reformulate these things. And for all these possibilities, we need role and process concept. And this is a short glance of what we found out, or what we, let's say, derived from the rules, a very simple role model. So first of all, we have somebody who's just looking at the library, who's a musician. He can browse the content, and he may eventually register as a member because he wants to take part in that process. Once he's a member, he can comment on the patterns, and he can provide evidence. This is known uses what I saw in your presentation before. Basically, yes, I see that pattern, I applied it on myself, it was successful or not, so he's providing the evidence of that. Also, very interesting project members or people who are working with domain analysis, they can become an author, they do submit the patterns. On the other hand side, in the middle we have the pattern library approach. And we have 2 control boards. One control board is checking the quality of all the submissions, are they complete and are they understandable? And then a structural decision board who does all this reconfiguration, realigning of the patterns, introducing hierarchy levels, for example, from the abstraction to the concrete patterns. So, having these roles in mind, what could the process look like? And we tried this one out here. So we first say, from the beginning, we have an author who submits a certain pattern. And we choose a submission, this is a proposal. And it is checked first, is the description complete? Or does it have to be clarified again? So it's not published at the moment. So it's the name, speaking, is meaningful, and things like that. Is there a solution inside? Then we already have a pattern which needs to be considered. If we do not have a solution, we're just documenting what we observed, doing our research. We we have an open problem. So we have something we're dealing with. How do we get firefighters to accept new technology while doing that process of finding civil people? This is the first state we're in. And basically now you wait until you have a solution and then you have a paradigm consideration. So let's say the basic required fields are filled. And the next step then would be to define certain aspects who tell you if a pattern is, for example, readable or if it's appropriate for the context of use. And to make it look a bit more complicated, we said we have each pattern has a quality gauge that's determined by aspects, for example, readability, completeness, appropriateness, up to a certain level. And for that, let's say, judgment, you can define a rating function. Make it a bit more concrete. In our example, we have a pattern library, which is very similar to what we saw from the time. Here we have the standard fields from problems to solutions. We have an iconic representation. We have a discussion going on. People can give their feedback.
I asked to fix it, unfortunately
They didn't.
do it with the rate.
Okay. Let's give it a try again. Okay. No.
Perhaps you can use the volume of your device.
Yeah. But then you can switch off.
I just switch it off. I just move on, sorry. Okay, what was I? So here we have the rating function that I said. We basically, in order to give all the project members a chance to take part, and not to be sort of complicated, we said, okay, give me a rating of that pattern. How readable is it? Do you understand what's written inside it relative to the project context? And with the rating function, we also define how many ratings do you need in order to advance to the next step. This is that's a prototypical implementation. We tried it out in the project I was just mentioning. So we said, for example, we need 2 to 4 ratings in order to move on. And you see the pattern is in the status of under construction. People are documenting or commenting what is still missing. They are adding certain aspects. And this may also be a clue that you need another pattern derived from the one you're working on. Let's go to the next step. Once you say the pattern is, let's say, the aspects of the pattern are clear, you can use that thing. You have a pattern candidate. You have a problem, you have a solution that looks good. Now you need to find the known uses, you need to find the evidence that support your pattern or that even refute your pattern. And also to express it a bit more complicated, say you have an evidence factor E for each pattern, which is basically just the sum of the cues you have, known uses. So how many prototypes are out there? How many implementations did I find? How many publications are there? So for each of these examples, you have an evidence factor. And you basically just collect them, plus or minus 1 in our case, supporting or refuting. And then from that we define the pattern maturity indicator, which is basically the sum of all this evidence we have. And we can say, for example, in our research project, since there are no publications at all, that are slightly related, they are not so strong as a working prototype. They are not so strong as an evaluation. So basically we just introduce the weight. Say the different evidences are weighted against each other and therefore added, summarized up, and then you have the pattern maturity indicator.
Who determines the weights?
You as a project or as a domain analysis or a pattern author, let's say, you have the rules for your project. Just in general. In our project let's say we have a survey, what is possible to be found there. So it really has to be determined by the project in this case. I don't have a pattern for defining patterns. Okay. Okay. So also back to another example where we talk about risk colors, the things I mentioned before. Red means, for example, big danger, ICU injury. Yellow means something in the middle, and green is something you have to keep an eye on. The rating is okay, so there's some good ratings so far. You have a certain level that has been achieved for the pattern, and evidence is being collected. In this case, we have publication on guidelines that support the idea of risk colors. Basically, we found out that the pattern is also proven by regulations in this case. All right. From that, basically, all we need to do in our project now is to wait until we find more evidence for the pattern. If you have enough evidence here, we really have an improved pattern you can reuse. Or you can say in our context, we are developing the knowledge from 0 to where we are now, that the knowledge is improved. And eventually can be transferred to another domain to another project. Also, how do we do that? We were talking about different abstraction levels, just like in the presentations before. So we have different levels of extraction. Or our Then things, how the domain works. So you have something like laws, and you have practices like firefighters, how do they actually work. It's sometimes the difference from what they do. And you have interaction concepts, you have prototypes, you have real, let's say, applications on a very low level. So we come from a very abstract guideline level or from the law level down to implementation. That's what I mean here by abstraction level of the bridge project. And then you can define a pattern maturity indicator, the sum of all the evidence you have per level. As I said, if you have risk colors, we need evidence in form of laws, of rules. But for the implementation, it could be something like successful prototypes. So what I'm after here is to say we can change the idea of evidence and weights to a level where we are. So also another example here is how we, for example, show the body injury, and this is the pattern that is now fully proved. We have enough evidence found. We see from the right-hand side, we find that we supporting evidence here, and the rating, of course, is now excellent, as you see, and this pattern becomes approved. It could have been in the progress of the project that this is not a pattern, that people refute it with your evidence and say, hey, the way you did it here, using cards or checkboxes, whatever, it does not work for our domain, forget it, but you still document this. And here we see the discussion that has been on the pattern. First, it was under consideration. People commented on that there are some other issues that need to be considered. But in the end, we have a very confident user. He said there's a very clear description. You can work with that. It basically catches all the things that are needed for it. Okay, let's go for the implementation here. So we use the Joomla content management system. So instead of a data wiki, we chose that approach. We have some experts who help us programming, and some master thesis derived from that. And what I just would like to say, we have widgets here, so we have the pattern component itself, so all the things that are visualizing the patterns, that are collecting them, editing, and so on. Now there's some modules, widgets who say announcement. Once you're here, you could also do a rating for this new pattern. Or once you're here, wouldn't you like to comment on this pattern? So we would like to show the liveliness of the approach. It may be that you're sitting in front of your desktop and say, am I the only one who's working here? And therefore we have these widgets who would like to show some activity, what has recently changed, who other users are also online. It points out incomplete patterns. We have something like a Hall of Fame. People who really work a lot, they are also shown as Man of the Month, for example. And this component also allows us to visualize the pattern library as a direct acyclic graph. So we put the patterns in context to each other. And this is the abstract example. Once you've understood what risk colors there are, red, yellow, green, black stands for disease in this case, so also monitor, you can understand what a domain practice is. So the firefighters and the ambulance run out and do a tagging. They really attach paper to people and write on their heads how severely they are injured. It's not a joke. It's just because you're running out of time. And once you've understood how this process works with paper, you can come up and say, hey, I've got an ICT solution here. We have a triage bracelet. So we basically reuse the colors, we reuse the process that is in there, and do not change anything. We just attach the electronics to it. In case it fails, we still have the colors, we still have the things you know. Or you can say, once you understood the risk colors, you know how to visualize risk on the map, the same color scheme. And here you see, maybe there is some domain practice inside we haven't captured yet. So send out your domain analysis, they have a look at that and ask back, is there a domain practice for, let's say, visualizing the risk on maps? That's a clue that maybe something's missing. This is the end result from the bridge project. We gathered around 40 patterns, 5 of them were in the approved state, and here you see all these, the first connections that we could make, just as an example that I was just also describing. This is basically the look at it. We have the widgets on the left-hand side, the Hall of Fame, the suggestion what you could do next. There are still parents who need some help, some of your help. And basically, that's a prototype we're working with. Let's summarize. What have we seen here? First of all, we have defined that approach a pattern maturation process. So it's possible now to, in a distributed manner, asynchronously to work patterns with human workers. That's very important. We don't have machines for doing all these things. We have collaborative review and feedback. Maybe I should mention again, we have projects, 60 European partners, different countries, especially far away. We could say you can't meet every week and talk about the patterns. So you need some tool where you can work on collaboratively. We have criteria defined about the validity, we have dynamic structure, and let's say basically or in principle we have the chance everybody in the project can take part because the process is quite easy to read. We have that in some evaluations, which I didn't show today, but you can look it up in our work. And we have defined the first set of rules and goals how to process from an idea to a parent candidate, maybe also to an improved parent. We have a prototype here, which is basically seen as extension. So also that's something everybody knows. So we have a low learning curve how to interact with such a web-based system. We have means for browsing, from contributing, and for providing feedback. And we can visualize the structure and activity throughout the project. And something here that comes back to your question, Frank, we have a flexible rule engine basically. We can define what kinds of ratings do we need. Maybe we have a semi-automated process who is basically mining something for us, so we don't have a rating function anymore. It depends a bit on what context you're working in. In our case, it was really understanding the domain, so we have a lot of new readable text. Maybe for software engineering, it's very different. So we do have a flexible rule engine we can just exchange because it's just a plugin in our system. Yeah, and we have a project-based case study. We show the benefits of usages. We have some suggestions what needs to be better in the future, and we know that we reflect the product research and development activities. And with that library, it's really possible to reflect the domain knowledge and to allow people to come into the project to learn from what was done before or another project in that domain. To just read through the patterns to get a first idea of what it was all about. So the outlook. We had some concepts that were discussed, that were also discussed this morning. We needed to maybe it makes sense to extend the relations. So not just say, hey, if you read this pattern, this may be interesting for you. In the examining approach, it was just like, we have 5 patterns that may be of interest, and it was an OR connection. You can read all of them, or you can just read one of them. But it's recommended to skim through all. Maybe it makes sense to say, if you just make a decision at that point for one pattern, you have an XOR definition now. You decide, you have pattern A, you need B, C, or D, and take just one of these solutions because you already you have made a decision in your design. Pattern sequences, we talk about all. Somebody who's new to a pattern library, maybe you give him some hints and say, hey, once you're new to the emergency response domain, you're a computer scientist like I am. You should read the first 20 patterns and then you understand how processes do work. So don't come up with a mobile phone solution and give it to the firefighter, for example. That doesn't work. Just to give that as a small motivation here. And also traceability and history. So what happens to our pattern over time? We did that with the discussions, we saw how ratings came in. So why did we need even to make it clearer how did we come to that pattern, how did we get that idea of formulating the way we have it now? And future work. A colleague of mine, Christian Fowler, also did that with source code documentation. He would like to assess the quality of the documented code, but also the authorship. If you have a collaborative project, many people are working on that. How do we trace back who contributed what? So it has to be authorship. And usually a pattern author is quite proud of his contribution, so we need somehow to honor that if he provides something and somebody else adds content to it that we have together. And of course, that's what we are currently running after, is to transfer that idea of collaboratively documenting project with patterns to different projects, different scopes, and also transferring that into industry as knowledge. And with these words, I hope it's still safe somehow the controversy. Yes, for the main words.
We can already see that the pattern topic is multifaceted. We have the human knowledge engineer taking center stage, and your approach. We heard about automation and automatic discovery of pattern candidates. That really shows that the community is diverse, heterogeneous, and it's a good thing. Questions, please. Yes.
So do you have a particular strategy to make practitioners and researchers adopt your methodology and system to in the future curate everything in the first place in this kind of framework in order to make it all compatible and get that in one place? So do you have any strategy to convince them to adopt this?
That's really the point. So convince the people of using the tools. It's always the same. You're basically in every project you are reinventing the wheel. Let's say you have very technical parts there. Say, I don't want to write any text. I don't want to do that. I don't want to use a wiki. I have my UML diagrams, whatever. And of course, we really have to convince them. We also have to convince them by the approach that I mentioned here, that was on that slide as far as I remember, that we say, hey, we do this, we do not do waterfall, we do not do specifications at the very beginning, we always go through. And during that process, you start introducing the tools, which is, for example, an issue tracker, the wiki, and maybe the panel language. And then we already had a hard job of introducing that into Bridge. And who could be convinced? Social sciences, psychology, my friends in computer science, but there are still some other disciplines who are a bit, to say that, they're a bit strict. They don't want to let you in, so it's a lot of work to do. But that's also a matter of negotiation at the project beginning. Okay, so we work together on this field approach, we pursue our proposal, and then you have committed before you start the project. So that's tricky.
More questions, please. What about the students?
So a chance to ask.
We have time for some more. We'll shift the coffee break a little bit. Actually, my question would be, what in your approach is specific to patents? Many of the things you talked about remind me of other knowledge engineering, knowledge management approaches. Because of the user asset specification or the OMG, your feedback cycle and the storing would be very well suited for other artifacts, for other assets, not just for patents.
Yeah, that's right. Basically, I also landed those approaches to the patent domain. Where I said, okay, normally we have the patent thing top down, expert is writing the patent. That was somewhat like feeling like, can we just reverse that process that you get the knowledge process with outsource? Yeah. Process, yeah.
So you would agree, it's more applicable to other.
It's very simple, yeah. Basically, this is a mixture of the re-engineering of different approaches we have. But now we're trying to become some patterns. And I think we haven't seen that mixture so far. But now we have, because 2 years later, we got to touch it.
No further questions? Everybody's ready for the coffee break? Yes.
And I need to steal you a few minutes, because some people weren't sure whether or not they are registered for Spina Longa. So briefly read the names, the ticky marks we have. It's Themis, of course, it's Veit, Frank, Johanna, Uwe, Michael Falkenthal, Johannes Wettinger, Matthias, Pascal, Tim, Walter Matthoff, Walter's wife, Holger, Jörg Lennart, Christoph, Christoph's wife, Rene, Antonio Esposito is registered, Felix Gessert, Marie Caroline Barendt, Bernhard Wolfgang, Kunal Suri, Winfried Lammersdorf, I can see. Daniela's husband, Ulf Schreier, Guido Wirz is here.